Okay, welcome to A levels computer science lessons, and we are going to start our AS first and starting from paper number 2, algorithm design and problem solving. Although we have around 8 chapters in paper 1 and we have 4 chapters in P2. So starting from algorithm design and problem solving. Now, what do you think about computational thinking? Any idea what is computational thinking? Like you said, sir, I'm using a computer and due to some issue, my computer was shut down. So I think that there must be some problem with my computer. The problem can be a RAM problem, like your RAM is not matched, eat it up. Or you can say, sir, my motherboard problem. Or you can say, sir, my power supply problem, isn't it? So there may be many problems, you think. RAM, motherboard problem, and power supply, right?
Yes.
But you don't know what is the exact problem because you are not the computer engineer and you're just a computer user and you're thinking that this might be my problem. What do you think?
Yes.
Okay, you wanted to travel somewhere, you start your car and your car won't start. What do you think? What will be the actual problem?
The
Maybe?
engine खराब हो गया.
Yes, very good. The engine problem. Or if I said there is a battery issue, car battery, is it possible? Yes, you can say, sir,
Yes.
bilkul. It is possible that my car battery is drained off. Or you said, sir, engine problem. Or you said, sir, my car dynamo. Dynamo is a part of the engine which provides the electric charge. Sir, my dynamo having some problem. So this thing is called computational thinking. That you are thinking about the problem. Did you get it?
Yes, sir.
Let me ask you one more thing. You are using a mobile phone and suddenly your mobile phone switched off. What do you think? What is the problem?
There may be battery का issue हो सकता है.
Very good. Maybe a battery issue. Maybe your mobile phone get virus, or maybe your mobile phone get heated up. So
Yeah.
you see, I'm giving you three options for each problem. This is called computational thinking. That you are going to think about the problem and you will find the actual problem. Understand or not?
Yes, understood.
This is called computational thinking. So let's see. Computational thinking is used to study a problem and formulate an effective solution that can be provided using a computer. So when your computer is shut down suddenly, so you go to the hardware shop and you said that my computer have a problem. So the hardware engineer inspect your computer and come to know that RAM have a problem. He said, Ramin, your RAM is out, is gone. You need to replace the RAM. You said, okay, replace it. So look, you have to provide a proper solution. So there are several techniques used in computational thinking, including abstraction, decomposition, algorithm, and pattern recognition. So when we talk about the computer or the computational thinking or the problem, so we have some different computational thinking techniques. What are the techniques? Abstraction, decomposition, pattern recognition, and algorithm. Is that okay?
Yes.
Perfect. Okay. Now, the point is abstraction. What is abstraction? Any idea?
सर बेसिकली एब्स्ट्रैक्शन ये होती है कि आप कोई बहुत कॉम्प्लेक्स चीज़ को थोड़ा कम कॉम्प्लेक्स कर
Exactly.
दो. जैसे मैप्स होते हैं आपके.
Very good. Abstraction means that you are going to use a relevant information only. Using what? A relevant information only. And you are going to leave the unnecessary things. Is that okay? So you are going to
Yeah.
pick only the relevant things and ignoring the unnecessary things. Getting it? So
Yes.
abstraction is an essential part of computational thinking. It enables computer scientists to clear or develop models for the solution to the complex problems. Abstraction involves extracting information that is essential. That's it. And you're going to ignore what is not relevant. So it includes what is necessary to solve the particular problem. So what do you think, Ramin? The computer engineer open your computer, he comes to know that your RAM is not working. And if he said that, Ramin, your RAM is not working, I'm going to replace it, and I also wanted to replace the power supply. What do you think? Did you allow the person to replace the power supply as well?
No.
No. Why? That is irrelevant right now. और तुम ये सोचो कि वो पैसे बनाना चाह रहा है. सही बात है. You think that he's charging 4,000 for the RAM and he's charging 6,000 for the power supply, so 10,000. तो तुम कहोगी भाई दिमाग खराब है, पागल नजर आ रही हूँ. क्यों पावर सप्लाई की चेंज कर रहे हो? इज्जत से रैम लगा दो, सिंपल. So you got, heat up. Why? Because you think that the person is going to con with you. So this is an irrelevant thing, na? So anybody can think this. Even I do so. I do so. Okay, भाई जो कहा है वो कर लो, ज़्यादा चीजें नहीं छेड़ो. So the point is, abstraction is the same thing. You are about to work on the exact thing, whatever the problem is, and do not touch the other things. So you see this map on your left, and this is the map on your right hand. So what do you think? Which one is better to use? Which map?
The one on the left.
Of course, the left one. Why? Because you said, sir, the left one have a very easy color scheme. Sir, the left one is a very easy to understand. And sir, I don't want this kind of hanky-panky in the map, that there are some valleys and bridges and patterns, roads and rivers and houses. So what I supposed to do with it? I need a road map, simple thing. So I have to go with the straightforward thing, and I'm using the left one. This is for abstraction. Now, what are the benefits of eliminating unnecessary characteristics? So the first thing, the time development is going to be reduced, because you're working on a thing which is exactly the same thing what you're looking for. So it saves your time. Number two, the program is smaller in size, so take up less space in memory. Of course, when you're going to create a program, and when you are using the abstraction technique, the program will become point to point, and it definitely saves your memory, definitely saves your time, and so on. Customer satisfaction is greater as their requirements are met without any extraneous features. So we don't need any extra feature. We need a simple solution with the point-to-point thinking, and that's it. So abstraction is the best technique for the programmer to develop the good program. The next part of your programming technique or computational thinking is decomposition. What is decomposition?
सर उसी तरह से होता है कि आप अपने प्रोग्राम को और इजी कर लेते हो और उसको डिवाइड कर देते हो छोटे पार्ट्स के अंदर.
So in simple wording, breaking down the system into systematic way is called decomposition. So in chemistry, we learn about decomposition. In chemistry, if you're talking about HCl, I think you're the chemistry student or not? HCl.
No.
What is the full form of HCl? Hydrochloric acid. So when you decompose it, break it, it becomes hydrogen and it becomes chlorine.
Chlorine.
Yes. In chemistry, we teach students like this, decomposition. But in computing, we make you understand the way that this is a program. You are breaking your program into the module 1 and module 2. In module 1, you have a module 1.1 and 1.2. In module 2, you have 2.1 and 2.2. So look, I am breaking down the big problem into the smaller step. This thing makes your understanding very easy. So decomposition is an essential part of the computational thinking. It enables computer scientists to break up a complex problem into the smaller steps. Achha, this thing is also called something else. This thing is also called subroutines. Do you remember O-level computer? Subroutine.
Yes.
This thing is also called subroutines. NE, subroutines. And this thing is also called structured programming. This thing, like decomposition, can be used in as many words, right? So okay, so it is divided into the smaller part until each part is easy to examine and understand. Any question?
No.
Okay, the third topic is pattern recognition. Okay, what is pattern recognition? Any idea?
No.
Okay, let's see pattern recognition. Just a second. Okay, what is the meaning of pattern?
Sir,
Pattern.
कोई
एक particular way to organize करने का. Yes. Okay, so let's see what is pattern recognition. It is used to identify those parts that are similar and could use the same solution. This leads to the development of reusable program code in the form of subroutines. I told you the subroutine means the part of the program. So when you are using when you're creating a solution of any problem, any program, you are using that parts which you use in decomposition. You use the same parts in your program again and again. So there are two parts of subroutines, procedures and functions, right? So subroutines divided into two parts, procedures and function. IGCSE computer, procedures and functions. I think you forget that. Procedure is going to use the task repeating many times in your program. Do you remember?
yes.
And we call
Yeah,
the
yeah.
procedure. And we call the procedure. So the same thing is in pattern recognition. In pattern recognition, you're going to make a solution of the problem, and you are going to use a subroutine. Like you're using the same solution anywhere in the part of the program. So when writing a computer program, each final part is defined as a separate program module that can be written and tested. So look, this is module 1. This is module 2. I'm going to write down the solution of my program. Now I need module 1. So I use look module 1 as a subroutine. Look. Then I continue my solution. Look. I again need module 1. So in this way, we are going to use the program code again and again in the program wherever it is necessary. So we have two types of subroutines. Procedures and functions can be used anywhere in the program.
Okay.
Is that okay? So program modules already written. Look, it is already written and tested, can also be identified and reused. Understand?
Yes.
Okay, just give me a second. Now, what you have to do, I'm going to give you a task. The task is you need to take out your notebook. Okay, in your notebook, you have to draw the columns like that. One is for decomposition and one is for abstraction. Is that okay?
Yes.
And I want 3 points for each in a column way, in a tabular form, right? 3 points for each. And I want 2 features of pattern recognition. PR, pattern recognition. You have 7 minutes. Now we are going to start a topic of algorithm. What is algorithm, Rami? A simple
Sir,
definition.
algorithm is like a method that you can use to write a program.
Exactly. If I'm going to use a definition, if I'm going to use an algorithm definition, so algorithms are the steps to create the program. That's it. Or algorithm is the recipe to make the to make the program. What do you think?
Yes.
Right? Acha, what I
Yeah.
feel, Ramin, that your basic concepts are missing. Right? Basic concepts are missing, what I feel. Okay? So algorithm are the steps to create a program, or you can say algorithm is a recipe to make the program. So what is the basic definition? I have done it. But is there any example? Okay. Let's suppose algorithm 1. Write an algorithm to print the sum of two numbers. Now, the question is, sir, what is this thing? I said write an algorithm. What is the meaning of that thing? It means write the step. About what? To print the sum of two numbers.
सर ये मैं करने की कोशिश करूँ
Sure. Tell me. Step 1.
सर
Yeah.
डिक्लेयर करेंगे
Oh, very good. Amazing. Amazing, girl. Come on, start. Declare.
declare num1
Yes.
integer,
Very,
declare num2 integer.
very good, Ramin. It means you remember the teaching, remember the things. That's good. Okay. Integer. Fine. Okay.
सर sum होगा declare
Nice. Sum is a function. Sum is going to apply the addition of two numbers. So the sum function.
input num1
Exactly. Simple. Input num1, comma num2. So we can do like that as well. Okay. Then
or sum equals to
yes.
num1 plus num2.
Very good. Num1 plus num2. And then
or print sum.
yes, that's it. Or if you said
Out.
I wanted to print num1 and num2 as well because I wanted to see the values, fine. Go ahead. Num1, comma num2, and then again output sum. That's it. So look, this is the basic steps to print the sum of two numbers. And that thing is called algorithm. So algorithm is a step to create the program. Any confusion?
No.
Perfect. Now, writing algorithms that provide the solution to the problem. So basically, how do we use the steps in algorithm? Like I use input, I use sum, I use output. These are the steps. So let's discuss how do we use the steps. So the first thing in our algorithm is a structured programming or structured English. It is a method of showing the logical steps in an algorithm using an agreed subset of straightforward English words. Tell me, the straightforward English word, declare, input,
Yes.
output, these are the English language words. But we are using it in our algorithm. That is called your structured English. That's called your structured English words. तुम ये भी कह सकती हो कि सर स्ट्रक्चर्ड इंग्लिश तो आपने आईजीसीएसई में भी ये भी तो पढ़ाया था कि pseudocodes कहलाते हैं. तो yes, they are formally called a pseudocode. Right?
Okay.
Yes. Okay. What is flowchart?
सिर्फ फ्लो चार्ट वो तो जिस symbols और lines वगैरह से वो
Symbols. So you
connect
can say,
होके
sir, we have
आप steps
exact IO box. We have a rectangle. We have a diagonal. Remember? Like that.
yes.
So these are all called flowchart. So we will discuss all these things later in the chapter. But right now, this is a steps like writing algorithm provide solution to the problem. So we are telling you the solution that how you deal writing an algorithm with the help of these solution. So structured English is done, flowchart is done, algorithm I told you is a way of showing a structured algorithm, or you can use flowchart. Yes, you can also use flowchart, right, as a structured program. So if you say, sir, instead of writing this whole algorithm using pseudocodes, am I going to draw the flowchart for that? Yes. You can represent your program in a way of flowchart as well. Right?
Yes.
I don't think so. You get it?
Yes, I get it.
Okay, what is pseudocode? Pseudocode is a method of showing the detailed logical step in an algorithm using keywords, identifiers with the meaningful names. Yes, what is a meaningful name here? Declare num1, num2. So look, number 1, number 2 is a meaningful name. Input, sum, output, these all are the words which we use in English as well as we use in our program as an algorithm. So that is also called your pseudocodes. Right? So pseudocode does not need to follow the syntax of a specific programming language. Yes, if you use Python, of course, I will make you use Python. And you said, sir, why you're not declaring the thing in Python? Because in Python, we are not going to declare the things. In Python, we are going to write down a straightforward program of only 2 or 3 lines. So you cannot say, sir, algorithm is a Python. No, algorithm is using in pseudocode, and pseudocode is an informal way to write a program. But in Python, you have to follow the formal way to write the program.
Okay.
So I'm going to use Python, inshallah, in the next lesson with you. So you will get the idea how Python works and how algorithm works.
सर वैसे पाइथन P4 में आता है ना?
Exactly. Python is a part of P4. हाँ बिल्कुल ऐसा ही है. P4 में हम लोग पढ़ते हैं Python और वो हमारा P4 होता है. And we have to sit on a computer in examination board center. And
PyCharm पे.
हाँ PyCharm. बिल्कुल PyCharm. Right?
Yes.
Okay, just a second. Okay, now what you have to do, Ramin, you need to write down algorithm definition, algorithm number 1. Once you finish, let me know. You need to write down only one sentence for each. Structured English, flowchart, pseudocode, whatever, right? But first you need to write down this. Okay?
Okay.
So this is a structured English example. Here you see, we are going to write down the steps like that. Right? So this is a structured English. But if you talk about the pseudocode, I explain you